Okay, good morning, everyone. Thank you for coming here today with us. As you were saying, today we are going to have a quick introduction to PRQA, and we're going to share our expertise on static analysis. My name is Gisella Albanesi. I'm an account manager for PRQA. I work in Italy and Spain, and I help existing customers like Magneti Marelli, Thales, Alstom, make the most out of their solutions. Today with me, there's Silvano Sogos. He's our technical manager, and he's going to deep dive into the more technical aspect of static analysis. We expect this seminar to last for about an hour, and at the end, we plan to have a short question and answer session. Today, we are going to see who is PRQA and what kind of solutions we offer. We're going to then challenge you. We're going to give you this piece of code. You have to identify errors, but I'll explain you a little bit more later. Then I will hand it over to Silvano. He will talk about static analysis, both from a theoretical point of view and the applications of it. Then we will see what one of our customers is doing with our solutions, if there's time. We'll find time.
The indication of the case study, because I don't have discussion on this.
Okay.
Otherwise, it would be too long. It's more longer than.
And then question and answers. So, who is PRQA? PRQA is a company established in the UK in 1985. We now have 3 offices around the world: London, Boston, and in India. We are just over 100 employees, and a lot of us, like 50%, are in research and development. We are pioneer in the static analysis market, and we are founding member of MISRA C and C++ communities. We are member of the ISO C++ committee, and we are the author of the High Integrity C++ coding guidelines. We have around 3,000 customers worldwide, and we focus on the verticals on the sector that is safety critical. So think about automotive, railways, avionics, medical devices. We are mostly known for our static analyzers, QAC and QAC++, but recently we have introduced other 2 languages, QAJ for Java and QAC#. We also have a slightly different solution, which is called QA Verify, which is a kind of an information hub. So it's a platform that allows people from various teams, like both developers, managers, or global managers, to all of them have access to the same data. I want now to show you a quick video about how a developer can benefit from our solutions. What have we done? L'avevo messo nell'H.
Però io ti ho copiato la chiavetta sul destro.
Ok. Facciamolo partire da lì.
Sì, no, aspetta, facciamo partire da destra. Però copia il sito.
Dove l'hai messo?
Sì, ma sono 81 mega, se lo puoi partire dall'USB ci metto una vita.
Just a little moment.
Software developers face many challenges, including application of internal and external coding governance, ensuring secure, functional, and compliant code production, efficient identification of issues within both new and legacy code, adapting to evolving requirements in an agile development environment, ensuring you find out about software issues before your customers do. Consider three aspects. Firstly, the functional integrity of the code, not only to verify that a given application works in isolation, but also that we can support a continuous integration methodology and ensure new applications work with existing systems. Secondly, we must ensure that both new and existing code streams are secure at the application level. Finally, we aspire to produce compliant code streams, whether that be to internal governance or external coding standards, or both. Using PRQA analyzers in combination with associated compliance and security modules, developers can automate interrogation of code streams and be proved with insight regarding errors, compliance, and security issues contained therein. Taking control of source code, both at point of creation and in legacy tools, helps assure better outcomes. Identifying functional, compliance, and security issues early in the development cycle promotes on-time delivery. Real-time reporting helps leaders stay appraised of both agile and waterfall projects. Complete chain of custody, from desktop to decision maker, ensures you're made aware of potential issues before your customers, providing the flexibility to rapidly respond to changing business drivers. Like to know more? Get in touch today.
Okay, let's move on to the developer's challenge. Okay, it's very easy. We are gonna end this out. You have to review the code, circle the issues, and add your comments. Please, don't forget to fill your details at the back, because it's gonna take Silvano a few days to check all the papers, so we are gonna probably announce the result in, let's say, a week. So we really need your details at the back, because otherwise we cannot give you the prizes. Which will be 3 Amazon vouchers, 50, 30, and 20 euros. That's just an example of how you are, just supposed to do it. What do we mean by adding your comments? Okay, now I'm gonna give
the second part of the presentation. A bit more in technical focus about static analysis. So the first thing is why we do static analysis. And I'm asking you, why do we do static analysis? Who tells me why? You are the smart one. Why do we do static analysis? No. Okay. There are some reasons, obviously. Okay. One reason is here. Okay, in this graph. This graph tells you the calculation of a metric. The metric is called Defect Removal Efficiency, DRE. It's a metric proposed by a guy who's called Capers-Jones. He's a pretty famous guy in terms of software quality, thought leadership. Okay, so he brought some really clever ideas about how to measure quality of code. And one of the metrics, one of the ways to compute software quality was exactly this one. So defect removal efficiency is the efficiency of a task in order to remove bugs from code, okay? And it's measured in percentage, which means that 100% would be an ideally perfect task that removes everything from the code base in terms of defects. And so, obviously, if you think that you are, I don't know, you have to decide what should I do to make my software more efficient, more bug-free, I have to choose maybe between these ones. Now, you know perfectly, because this is what you learn in this course, that these are not substitution methods, meaning that all these methods are required in a structured software lifecycle, especially for automotive. But each one of the methods is going to aim and tackle a different aspect of bug detection. So as you can see, defect removal efficiency is higher in static analysis and formal code inspection. Formal code inspection means people together that analyze code. So it's a manual activity. Static analysis is automatic. So possibly the biggest importance of static analysis is that it's something that you can run automatically. And obviously you can understand that this means that it's going to be cheaper. If you have to account for the time of people reviewing 1,000 lines of code, it's going to be really huge and so really expensive. On the other way, if you are accounting for a tool that is used to analyze your code, it's going to be the cost of the tool when you purchase the tool. And then the more you use, the smoother and the cleaner is the return of investment. Okay, this is something that you have to start thinking about, because in the future, in your future, are considerations that will be really important. Second aspect is compliancy. You are, I think, pretty familiar with the last row. So functional safety for automotive, ISO 26262. But all the other ones are functional safety standards. So in other markets, there are functional safety standards. This is for nuclear. EN 50128 is for rails. There is a whole collection of 512X standards for functional safety in railways. IEC 62304 is for biomedical. And the 0178 is a collection of software functional safety aspects for airborne systems, so for avionics. All these systems require, in a way or in another, to manage the quality of software. And many of them, depending on the safety integrity level, which is, I think, a term that you are familiar with, okay? In automotive, we speak about automotive safety integrity level, ASIL. In the other ones, we speak about SIL, so safety integrity level. But the concept is already the same. So the reduction of risk and a qualitative indication of the safety of the tool. So the higher the level, the most demanding are the activities that you have to perform in order to validate the tool, the device that you are developing, okay? So specifically for tools ASIL D, ASIL C, for tools in other applications that are anyway SIL 4, for example, you have to perform static analysis. And you have also to use coding standards. So this is the third element. You have to enforce coding standards. I will give you some indication of coding standards. In general, I think that you are already familiar with MISRA. I won't give too much detail about this because it's something that would require a whole cycle of lessons about that. But anyway, for what concerns functional safety, the MISRA suite, and specifically MISRA C, is possibly the most widespread coding standard in terms of adoption. Now the version of MISRA C that is mostly used is MISRA C 2004, but MISRA C 2012 is quickly catching up. Okay, so this is the type of standard that maybe you want to look more in detail if you want to work in this area. It's going to be something that is normally required to V&V engineers, okay, to know what is the process, to know what is the requirements and so on. The guidelines are really well done from this point of view, so they are really easy to study. What I want to discuss now is a bit more about the technical structure of a static analyzer and some concepts. Maybe in the future you will have to decide to compare between different competitors to buy a tool. So these are general considerations. They are not even only for static analyzer, can be also for dynamic analyzer, for example. So static analyzer are analyzers that analyze code statically, and they can be subject to two different behaviors of error, if you want. False positives and false negatives. Okay, so you assess in the first instance the quality of a static analyzer against a test suite that you decide and that you know very well. Maybe you made a code review on that, and you try to spot the weaknesses of the tool against these two dimensions. How is it good in detecting all the defects? And how is it good and not be tricked giving you too many of them, even those ones that don't exist? So we speak about completeness and we speak about soundness. These are not, let's say, generally accepted terms, are pretty common, but there is no standardization on this kind of terms, okay? The idea of creating a chart like this is that an ideally good tool would position himself on the top right corner, meaning that it has no false positives and reports all the violations, so it's complete, which means that it has no false negatives. So false positives are issues that the tool detects, but they are not there. So they are false issues. On the other hand, false negatives are issues that they are true, so they exist, but the tool doesn't find them. You have always to think that in general analysis tools, so not only static analysis, dynamic analysis tools, analysis tools for binaries and so on, they are always subject to a trade-off in this kind of thing, okay? So there is no perfection in the concept of completeness and soundness. The perfectly sound and complete static analysis doesn't exist. There is a reason, and this is more referred to MISRA, let's say, which is the ultimate problem. So some rules of MISRA are so-called undecidable. Undecidable means that the type of check that the rule is performing is by definition, is not possible for a tool to provide you a yes or a no in all the instances of the issue. Okay, this is the definition that MISRA gives of undecidability. And this refers to a theoretical problem. It's not even a limitation of the tool, okay? Means that the problem can always be translated to the ultimate problem. And we know that the ultimate problem doesn't have a solution. This doesn't mean, though, so this is the undecidability. This doesn't mean, though, that the static analysis tool cannot be useful. So one big differentiation, if you want, in the quality of static analyzers is about how they treat undecidability. Undecidability is, as I said, a problem which is, if you want, doesn't have an answer in every instance. Doesn't mean that I cannot give you at least one answer, one qualitative answer, when I'm facing that kind of problem. So what is the concept here? Here, the concept is of usefulness. Okay, is it useful? It's giving me an indication of where can be the problem and maybe giving me the responsibility to check for the problem. This is already useful. Just imagine in automotive is a really good field because it's millions of lines of code, okay? So it's typically exactly the domain that you want, where you want an automatic system to run. And if the automatic system is able to tell you, look, I don't know for sure if this is going to be a problem. So I'm giving you a level of error that can be possible, for example. We will see what does it mean. I'm already giving you value because I'm focusing your attention on a specific spot of the software that can need a manual inspection. Instead, other tools prefer to treat undecidability in terms of it's undecidable, we don't care. So we don't give you the mapping. This is a really important part because the trivial checks on code are already done by the compiler normally. If you compile with a warning level all, for example, in GCC, you got all, or in Clang is even better from that point of view in terms of output diagnostic output. It's really complete. The trivial ones, the trivial checks are already performed there. So the quality of a static analyzer term comes exactly in this kind of area of the language. And obviously, the tool has to do trade-offs, okay? Which means that basically it has to choose between precision, scalability, and performances. What does it mean? So precision is, as we said, the ability of the tool to provide you with the information that you need and don't provide you with excessive information, which we call noise, and normally is associated with false positives. Scalability means that the tool should behave in the same way if it's analyzing 10,000 lines of code or 10 million lines of code. Okay, obviously you expect to have a linear growth in terms of time required, but there shouldn't be any type of complexity, added complexity only because the code is growing. And the same goes for performances. If I want a deep analysis of my code, so if I want to activate Dataflow, for example, we will speak a bit about Dataflow, I expect that the performance is not so dramatically impacted. Okay, it shouldn't be, because anyway, I need those results. So I want the depth of results, I want performances, and I want scalability. Each tool decides in this ideal triangle where to position themselves. So this is a bit more an information about how our tool is done. Many tools behave in many different ways. The basic structure is pretty common, okay? You will find this kind of structure also in our competitors. The type of evolution that we add, though, is going to be a bit different. So we have our analysis is done by components. Okay, we combine different components to do different analysis. The primary component is the basic component for that language. So let's say that you want to analyze C. It's going to be a component which is called QAC and runs the analysis. In the primary component, there is also a Dataflow engine. We will discuss a bit more about that. Obviously, feel free to stop me in any moment for questions or whatever, okay? On top of primary analysis, we can build compliance model. Compliance models are those components of the analysis that are used to enforce a specific coding standard. Okay, so we can have compliance model for MISRA, we can have compliance model for JSF, for example, is a coding standard which is used in avionics. It was the coding standard in C++ used for the F-35 project. Other coding standards that are used are, for example, MISRA C++ is used for C++ coding. High integrity is a coding standard we develop. If you are coding or you are going, possibly you will go into code in C++, I suggest you to download that. You can download that for free. And it's a really good, interesting coding standard because it's not oriented only to safety critical markets, but it's a good practice C++ coding standard. And we had other coding standards that are commonly used are the CERT coding standards for security. So you can go in the CERT website and watch those coding standards. They are for free. They are a collaborative project, so you can also interact with the authors, propose modifications if you think that some rules can be improved, and so on and so forth. So it's really interesting. In the CERT website, which is run by a department of the Carnegie Mellon University, there are coding standards for C, C++, Java, and I think also Perl. I'm not completely sure, but there should be also Perl. So basically, it's another interesting side. These are parts of the tool that run translation unit by translation unit. So translation unit in isolation. When I speak about translation unit, I'm trying to put together because I think that you come from different experiences. So translation unit, you have the C file, you have the include directives. What the compilers do when they start compiling is for first expand the include files, translate all the macros, so we say expand the macros. I substitute the value of the macro, so the define, #define, with this actual value in all the code. This is called translation unit. Okay, this first expansion is called translation unit. It is a C file with all these operations. And so I can start compile the file. From our point of view, it's exactly the same. We do exactly the same stuff. So we expanded the macros. We expanded the include files, the include header files that are included in the C code, and we analyze that. So up to that moment, we are exactly like a compiler. The behavior is changing from this moment onwards. So the analysis is done translation unit by translation unit. What you see here, and I will give you a bit more detail, is the whole project analysis, which means that there are issues that can be found only if we consider the project in its whole integrity, not picking one translation unit by one translation unit. I have to put all together, and I can find other issues. These are issues that maybe your linker would find, okay? But you have always to think that static analysis has a huge advantage. It doesn't require you to compile. When you are thinking about millions of lines of code, compile time is hours, even days. One of our main customers, which is Bosch, has systems that sometimes to compile get the whole weekend. They start that on Friday, and on Monday still compiling. The analysis can take also 4 days. And they don't, and not even at the highest level, at the deepest level, because it's really a huge code base. So obviously, this kind of approach can be interesting because I can analyze this before running the compilation, and I can be fairly sure that at least the compilation, if it has any issue, won't be an issue so apparent, something that's so trivial that a static analyzer could have found that in the first instance. So primary analysis, we said the primary analysis are the trivial things that a static analyzer can find. You know that C specifically is a really tough language. Okay, most of the people says oh, no, it's a simple language. It's a simple in terms of constructs, let's say. It's really hard to understand the language. It's really easy to get fooled by the language, okay? Because C comes from a long history. So in C, there is no strong typing model, for example. It's a weak type model. Everything is an integer in C. So if you know what you are doing, that's perfect. And the seasoned developer will know everything. But you are not seasoned developer. And so you can make errors. It's normal. It's part of the learning curve. But if you are writing code that goes on, I don't know, on the power drive of a machine, it's not so good to make errors, right? So the type of errors that are subject, really common subject of the C developer, junior C developer, let's say, common experience, are all avoided by the MISRA guideline. So the MISRA guideline was born with the idea that we can create a better language than C on top of C. Many people will say to you, it's a subset. It's not properly a subset, because the idea is to avoid all the areas of C that can be a problem. We speak about undefined behavior, unspecified behavior, implementation defined behavior, all this stuff that I will skip. But anyway, these are subject of the C standard that can be a problem. But MISRA gives you also a strong type model for your types. So it creates a virtual type modeling. So it's more than a subset, it's a new language, if you want. And so primary analysis avoids all the issues on C. So for now, we don't care about MISRA. In primary analysis, there is a component, an engine, which is called, in our case, is deep flow data flow analysis, which is a data flow analysis. To be honest, it is a data flow and control flow analysis. So if you studied already this, well, it's pretty intuitive from the name what is data flow and control flow. I try to follow the values of data and to follow the control flow of the program to see if there can be problems. Okay, the basic idea is really, really easy. Data flow in his structure instead is really complex. The type of issues are invariant operations. For example, you can find a situation where there is a condition which is always false or always true. Redundant operations, so maybe an assignment, then you don't use the variable and then you reassign the variable, so it's a redundant operation. Control flow, dead code and unreachable code are two conditions that MISRA forbids. So for example, when you will start developing code for automotive according to the MISRA standard, you will have a tool that will tell you, look, you are not getting in this part of your code. You are not reaching this part of your code. This part of your code is dead. And so you have to remove that. Or if you need that, there are situations that you may need that specifically if you are doing something called defensive programming. You will have to give a motivation. So it's called a deviation, okay? And then Dataflow does tracking of initialization, tracking of values, and tracking of pointers. Where tracking means I'm following the value of this variable across all its lifetime to see if there can be problems at any point. The type of messages are these ones. There are basically 5 levels of messages. There are constant messages. This is a message. We have numbers for the messages, okay? And we have basically 3,000 different messages in our message set, so many, many messages. This message says, look, you are referencing an invalid pointer value because there is an array declares on a pointer, and I'm trying to access the 100th element of the pointer where a buffer has been declared as 25 in size. So, but this theoretically doesn't even require data flow, because it doesn't even require to track the value. This is already known. So in our system, for example, we don't even engage the data flow for this kind of issues. We start engaging the data flow for this kind of issues. Data flow is useful for this reason, okay, this type of reason, because it's giving you issues when you engage a certain path in your code. So something that is not going to happen always. This is still happening, so it's a definite, so it's going to happen every time. It's just a substitution of a variable. But this is one of the main levels, so it's apparent. Apparent is about either there is a redundant path or you have an issue. And in this case, obviously, you are going to have an issue because you are testing for if a variable is higher or greater than 10, and then you have a message to wait for 2. And a similar situation is so-called suspicious. So suspicious is, look, if you don't get to the AAA location, which means that I'm reinitializing assigning 0 to the variable, when I'm going here, there is going to be a problem because J originally was 10 on an array of 5. So you see that can be complex because you have to focus in your way always to translate these samples, which are really trivial ones, to a huge code base where you are programming your embedded system. And this situation can happen in really unrelated parts of the code. And in code review can be really hard to depict all the path in this way, almost impossible. Okay. And so you have a suspicious message. And finally, I was mentioning this before, the level of ignorance of the tool is I don't know. It's called possible. And it's telling you, I don't know, but for what I can see here, since an unsigned integer is allowed to be 0, this can be a problem. Maybe you are really smart and you are calling this foo function only with values that are not 0, but maybe you are not so smart. And so you will forget. Maybe you will call this function from another translation unit where you don't have the definition, so you don't know. You are trusting the function, and this possible will become a definite, which means that it's going to be an error. So this was Dataflow. Compliance module, as I told you, is our components that we associate, and we speak about secondary analysis in this case, are components that remap all those 3,000 messages according to the rules of a specific coding standard. That can be MISRA, as I told you, can be JSF, can be other different coding standards. You can create also your own coding standard. MISRA, for example, is a coding standard that says, okay, these are the guidelines. Nothing prevents you to create something more restrictive, okay? Now you can have a super MISRA, which is a MISRA plus another coding standard, as long as you keep the guidelines true. Then we have many customers, for example, again, I can mention Bosch. Bosch has a coding standard, which is MISRA, and on top of coding standard has a naming convention. Naming convention because they need, MISRA doesn't give you any indication of what should be your naming convention. It just tells you, okay, you should have one, but I don't tell you which one. You can have Hungarian notation, you can have whatever you want, as long as it's existing and consistent. Bosch has a component that enforces that the integers are called in a certain way, the functions are called in a certain way. Some coding standards, they can also ask you to put information in the comments. And this is, for example, something that is not statically enforceable, which means that if you think about us, okay, let's say that you come in our company and say, okay, I have to start developing a coding standard, a static analyzer. How can I check for a rule that says me, you should put information in comment? I just can check if there is a comment, but I cannot check semantically what is the meaning of the content and if it's related. This is a higher level of knowledge that a static analyzer cannot do at the moment. I don't know if it will do in the future. So some coding standards can be more demanding. We give this type of task to the compliance modules. So these two levels are translation unit by translation unit. And then we have the task of the whole project analysis. So we run some analysis across all the project. Which type of analysis? We have two modules for this. One is called Relational cross-module analysis. And it's type of errors that are found at linking stage. Typically, you are declaring an extern of a function in a translation unit, and then you declare the same function in another translation unit and define that, but with a different signature, for example. So this is something that is not found at compile stage, it's found at linking stage, because the compiler will know when it's compiling translation unit per translation unit, will trust you. You are getting an external declaration, okay, I trust you is going to be that function. And it's only the linker that will put together and says, no, this doesn't match so well. So this is one of the situations. Other situations are recursive function. Okay, recursive function, there are two ways of making a recursive function. You can have a recursive function which is calling itself inside the same translation unit, and this, by definition, wouldn't require a whole project analysis, because you can find that in translation unit. The reason why we have that in the whole project analysis is that there can be also an indirect recursive system where I'm calling a function is calling another one, and the other one is calling the first one. And this function can be in different translation unit. So there is a recursion, but the recursion is indirect. And only if you analyze the full project, you are going to find that. And this is basically our latest component in terms of time of development. It's called MTR. MTR means multi-threading and resource analysis. And basically does exactly that. So it finds errors, let's say data races in terms of multi-threading usage, and resource leakage. So for example, not closing files, double free memory, stuff like that. So these are the basic structure of our system. Some concepts here are not so related only with our system. Every static analysis, let's say, of the level of our static analysis tool, they have this kind of features, and are useful for you it's useful for you to familiarize with that. One is suppression and deviation. Okay, all the coding standards, but Misra does this in a really good way. All coding standards have the concept of suppression. Suppression means that at some point you will have the evidence that you are violating a rule. But you would say, okay, I'm violating a rule, but I have perfect, good reasons to do that. I don't want to correct my code because the rule says so. Because I know that from the functional safety aspect, the violation that I'm doing is safe. Okay? Doesn't have any type of problem. Misra knows that. One of the main things that happened to me is normally having customers, we were discussing before this, a tier 2 customer that has been coding in the artisanal way. It says, okay, but I have this kind of thing is working. Now I have my customer is telling me that I should have this code Misra compliant. So yeah, I'm buying your tool, I have the money, but I have an issue. I have 50,000 violation. Oh, okay, you have a definite issue, a big issue. How can I solve that? Okay, not my problem, but if I can give you an advice, the next time start using Misra from the onset, not from the final thing. Because many of the violations, the violations are, I'm starting putting casts everywhere. Because a typical situation of Misra is you should put an explicit cast of your assignment, your operations that have an implicit promotion of integrals, and so on and so forth. So explicit cast. But you don't solve everything with explicit cast. Okay? It's not going to be only that. Some of the violations of Misra are against the things that are at design stage, okay? And these are the toughest one to resolve. Some other violations are more interesting. As example, Misra says you shouldn't use dynamic memory, okay? No dynamic memory allocation. Now, when you see this thing for the first time, or when you are that kind of person that doesn't care about studying things or understanding things, but they have to apply this because it has to be done fast, they will tell you, oh no, it's not impossible. I need to use dynamic memory. But Misra doesn't say that you cannot use dynamic memory every time. You shouldn't use, but you are allowed the deviations. A dynamic memory is a rule that is allowed a deviation if you provide a sound technical reason for that. In fact, there are other rules about what you should do with dynamic memory. So it's kind of self-contradictory, but only if you don't know what is Misra. Misra is a guideline, so it's telling you, you should care about this, 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 and this. If you think that you shouldn't, meaning that you think that you have to violate that rule, provide me the reason. There is a structured approach to the deviation, which calls also someone who takes responsibility for that. So a deviation record in Misra is a complete set of information which says I'm deviating this rule for this reason. I know that it's not going to be a problem for this reason, so I made a risk analysis on this. And there is going to be Mr. XY who's going to give me the authorization for this, because the person inside our company is the person who has the authorization. So from your point of view of junior developers, it's perfect. You ask the deviation, then it's going to be the senior one who's carrying on the responsibility. Perfect. It's really good, I mean, from this point of view, right? Suppression and deviations are exactly this process. With suppression, we mean that we give you the possibility directly on the tool to suppress messages. There is a semantic, a comment-based semantic in our tool. We have a tag, which is PRQA. So we comment with PRQA S and the message, and that message will be suppressed. But will be still tracked by the tool, and this is the important thing. If you are going to do a suppress report, the message will pop up there. So it's not going to be deleted. It's just hidden, and it's giving you tracking of the information that you choose to suppress this. And then it's going to be your duty to decide how to give formal indication. We have the other tool that Gisella was mentioning, that is QA Verify, is our tool to manage these kind of things. But it can be done in other ways. MISRA doesn't force you to buy QA Verify, unfortunately, but tells you you should have a structured management of the deviation. Baselining is the other important concept that you will find in automotive, especially. And this is the concept that is common in functional safety. So functional safety, from the point of view of software now I'm talking about, and so from the point of view also of application of coding standards, is something that is relatively young. It's not so old. The first guideline of MISRA is 1998. Okay, so it's not so old, let's say. So there was the issue of the legacy code that was already existing. It was totally not MISRA compliant, because if I took the code, the legacy code maybe coming from 30 years, it's going to be a layering. It's like the soil, terrain, right? A layering of different styles, different conventions, because it's the history of a company, if you want. But the company doesn't want to throw away the code in its entirety. Maybe it's going to rewrite that in the future, but the concept is, as long as it's working, is okay. Okay. And so MISRA has the concept of baselining, of legacy code as a reason to accept the deviations. So interaction with legacy code that has to be proven in field. So it means that there is evidence that the code is functionally safe. So MISRA says, okay, maybe you have been using this 10 years. Nobody died. It's safe. This is the concept. You can use that. It's not going to be MISRA compliant, maybe, but you can build on top of that a MISRA compliant application. Now comes the problem. If I use that code in my analyzer, the code is going to be not MISRA compliant. I'm going to put a lot of violations, a lot of messages on that. So we have a system which is called baselining. Baselining says, okay, I'm finding those issues, but I'm giving you a 0 message. Okay, I'm giving you 0 from here on. Every new introduction, every new modification of the code will be analyzed like a difference between the new one and the old one. And so I'm giving you only messages related to the new code. I'm still tracking everything, but the messages are going to be only for the new one. So you can treat new code differently from the existing code. And this is the concept of baseline. And this basically terminates my quick presentation, let's say. I'd like to know if you have questions. Gisella was referring to a case study. You can download the case study directly. I won't present you too much about the case study. It's Protean is a company who makes electric drives for mobile systems. And we help them to achieve ISO 26262 verification on their systems. if you download the white paper, there should be a really quick description of the decomposition. It was interesting because they have a decomposition problem in terms of ASIL for their system. So they were able to have an ASIL system which was a lower level, ASIL system with a higher level. Was pretty interesting one. But I suggest you, rather than having me presenting the case study, to download the white paper and read that. We have also the white papers on rates, which are pretty interesting ones, and basically that's it. Questions? Come on, at least one. Invent one question.
I have a question.
Okay.
Today we are seeing a lot of auto-coding.
Mm-hmm.
So we start from model, then we click the button, and we have a perfect code out of the auto-coding.
Okay.
So how do you, can be still on the market with auto-coding?
We can, because MISRA tells you that you have to be compliant also with the auto generator. Obviously, we have a strong competitor that is the static analyzer of MathWorks. So this is going to be obviously an issue. But the type of, you have always to think about this in two levels. One level is the compliancy, and for us, can be a really tough competitor in compliance terms. In terms of quality, can be interesting still to run the auto-generated code against a tool like us, because we can find normally better things. And then you can go to MathWorks and say, why do you have this kind of issues? You have always to keep in mind, also can be useful for who doesn't know. MISRA tells you that you should treat the auto-generated code in a slightly relaxed way in terms of rules, because there are some rules which are aimed to readability of the code. And obviously, if you are a sound and complete model-driven development system, you are not going to have readability issues because nobody reads the code. It's just machine-machine. But hybrid systems, which are, I'm running the model, I'm generating the code, and then I'm tweaking directly the code, they fall back to the first condition. So they are like if human developed everything. So MISRA doesn't give you any type of advantage on that. And we have many customers that do stuff like that. So they basically refine the code auto-generated with manual inspection. So yeah, but yes, they are tough competitors. Other questions?
Idea to them, which is the, let's say, type of customers that you have for this kind of tools?
Sure. Okay, we were born with automotive. So we were actually founding members of MISRA. So we were involved in the MISRA committee from the onset. So our main customers were automotive. As I said, Bosch, Continental is a big customer. All the big names are our customers. Then we started with a period in having avionics customers, which are pretty big ones. And now the point is that MISRA is kind of a coding standard which is taken from everyone. Even Internet of Things, that is that magic things that everybody speaks about and nobody understands exactly what is an Internet of thing. I would say just connected things. Even connected things are trying to find a standardized way to code, which can be safe and sound. They have different needs, obviously, because the functional safety aspect is really limited, let's say, really structured. And it's not said that a component of a connected device is going to have functional safety needs. But they need reference, and MISRA has the best track record. So there are no other coding standards that have the same history. So it happens that people start saying, okay, but it's for automotive. No, it's for C, or it's for C++. It's not for automotive. And then there is no C with wheels, okay? There is no driving C, it's C. So the type, the idea that, in my opinion, is really good in MISRA is giving you questions rather than rules. These are NISA calls about guidelines, but in my opinion are questions. It's like, do you need the dynamic memory? If you do need dynamic memory, give me the reason. Do you need to do this? If you need to do this, give me the reason. One pretty silly error of programming, which is pretty common also in the kernel of Linux, is having an if condition and immediately the dependency without brackets. Because the developer knew that there was only a dependency, and C allows you to do that. But again, you knew that. But I'm coming after 5 years, and I completely forgot that. And so I'm putting another instruction below, because maybe I'm a Python developer, and so I think that everything will be dependent on that case because there are tabs, and instead that we are C developers and it doesn't happen this way. And I fail to have the dependency. And for example, the go to fail bug of Apple was something that was depending from having a go to fail and a go to fail in a dependencies of a if. And a coding standard would have found that. And the funny thing is that they had the tool, but they didn't run that. They had the tool implemented in the iOS system development, but they didn't run that. And a stupid coding standard would have saved them a substantial amount of resources. So yeah. What is the discussion for testing?
We can discuss. We will probably have to have something signed by you. If you agree with that, then we can give you trial licenses or longer period, depending if you have a project to work on.
We are under discussion because they are very open to support universities for the discussion we had. We are in the process of signing for an evaluation version. So I think we could extend this to students as well. Then, depending on the outcome of the evaluation, it could be further, say, improvement in the relationship so that we can have this tool as a normal offer for technical students. We are under discussion. But in the very short term, I think that with the backup of myself as a teacher here at Polytechnico, we can provide a few evaluation licenses. Well, you can provide.
I can, definitely, actually. It goes down to you in the end.
Okay, I think that it's time for thanking you.
Thank you. Thank you. Thank you.